Cool. Hi, everybody. My name is Kent Gruber, and today we're going to be going over Hack Like a Gopher. We'll understand what that means, hopefully, by the end of the talk. Again, my name is Kent, and I go by PyCat online. Sometimes there's a Z at the end. Sometimes there's not. Depends on if PyCat was taken. I go by Kent Gruber on Twitter, and also the same thing on Medium, because they're linked like that. I write about a lot of stuff. If you go check out my blog and Medium. For example, this is one project I did pretty recently. Using Terraform, Docker, and Slack to kind of build like information security, cyber competition infrastructure for my team, so they could just go on Slack. They could say, I want to join the environment. They get a private SSH key that they can then SSH into the system, and they, underneath that long thing, they get the IP address and the actual command they can just go run in their shell. And then they can go have a Docker instance. They can go practice different commands and stuff like that, and then it's all cleaned up after they exit out of the instance. And now it's all managed just with simple SSH keys and basically a Docker command. And so I like building out stuff like that and then writing about it and trying to share the kind of stuff I like building. Weird stuff, too, sometimes, just like packet analysis in color. So you have packets and you analyze them in tools like Wireshark probably all the time, maybe just like TCP dump or whatever. But I was sort of just like had the question, like, what do they look like? You know, like, how could I like visualize that in some way? And it was actually relatively pretty easy. Like, this is the actual code in order to do that. And then you get something like that on your command line if you were to like visualize and just like analyze your traffic. Just through that. And that's just like 256 color in your command line. And that's just kind of a weird thing. Though, like all those little blue lines, those are all pings to Google. So like the weird stuff, I was actually able to like see kind of just a weird pattern just in like a network traffic level without even doing any protocol analyzation. I could like know, like I'm pinging out to Google whenever I saw those blue, those tealish lines, interestingly. Also, like more like kind of reverse engineering stuff. I wrote a blog post. Someone released a challenge, a Crack Me challenge on Twitter. There's all sorts of Crack Me challenges, like figure out how to log in and whatever, right? So this one was basically like crack me and then figure out the login. I tried foobar or whatever, and it wasn't working. So that's great. So I loaded up in that Binary Ninja to try to do some static analysis on it. I really fell in love with Binary Ninja after I got a free license. I came second place with my team at ISTS one year, and we got a free year of Binary Ninja. So I really fell in love with Binary Ninja because I had access to it, even though it is pretty cheap, especially for students. And then, like, going over, like, this is, like, all the functions. This is what it looks like, actually, visually. Like, I really like Binary Ninja specifically for its, intermediary languages. It has two, like, medium and low level, and it allows you to get, like, these nice disassembly graphs, which you get in other tools. Though I really do like, Binary Ninja specifically. And I like looking for like the flow, and I remember I found like this flow down here to like a pretty significant conditional statement. And basically, if I were to just read memory at the addresses that it was kind of basically associating with at that time, I was able to see like the string that I gave in meow, and then the thing that I was checking against Nixie. And then if I just threw that in there, I actually cracked it, and so I won that challenge, and that was great, and he posted it on Twitter. And I love stuff like that. I love the community specifically. I love sharing. I love when people do challenges. I'll definitely actually try them. You can find a lot of my code on GitHub. I do a lot of open source development. There are a few of my projects. These are my pinned repositories on GitHub. And it kind of is a decent representation of sort of the stuff that I'm doing right now. There's like a Falcon malware sandbox API connector that's related to reverse IT, and hybrid analysis, which are like the same platform, just under different domains. And stuff like a lot of Ruby, there's Crystal, and there's Go, and I do some other languages. These are sort of the languages I deal with in my spare time the most. Basically, a lot of different languages. Depends on what I'm doing, the right tool for the job. Maybe there's already an API thing that was already built in Python, and maybe I'm going to go make the Ruby version later, but I might just use that for the time being. And it's pretty easy to pick up multiple programming languages once you start picking up multiple programming languages. There's a lot of patterns in between them, and you can kind of get a feel for them, and it becomes pretty easy. And so I just love programming. One of the projects that I like working on open source the most right now specifically is BetterCap. I've been a contributor to the BetterCap project for a while now, ever since it was actually a version written in Ruby, though BetterCap has gone from Ruby to Go recently, and that kind of spawned my interest in Go a lot more hardcore because a project that I was working on was basically switching So Evil Socket, the main developer of BetterCap, let me know that we were moving from Ruby to Go. He even did a thing on Twitter about it, and was like, this is where we're going to be moving to. And I was like, all right, well, I better get on that. And I haven't regretted it. I haven't regretted it at all. I really loved picking up Go. There was a gradual learning curve to it. Like there's a learning curve to all languages, though you'll hear a lot in Go, either from the community or in documentation, that it's simple. And I would argue that that's probably mostly true, though there are a lot of things in Go that aren't necessarily simple. And I'm going to try to cover those things along with a lot of things that I like about it. So today we're going to be exploring Golang. So I'm excited about that. So yeah, Go. This is the Gopher that you'll see with the Go project, and I think he's really cute. So if you have any reason to pick up a programming language or pick up a project in open source or whatever, the logo tends to be a pretty big part, at least for me. That's why I actually did, if I were to go back for a second, I did that logo, turned like the Golang Gopher, and I threw a ninja mask on him, and I was like, here we go, we got a new logo. And it was pretty fun. It was just like, it was honestly like an hour or two, and I really enjoyed doing those kinds of things, contributing in those ways. And yeah, Go. I love that little Gopher. I love the community behind it, and I love programming in it. So hopefully I can kind of share some of that love for that really does stem from kind of that cuteness, right? But one thing that's actually kind of recent, before I even submitted this talk, Go came out with a new logo in that time. Go has been around, I believe, 8 years. It's a pretty new language compared to other languages that have been around for much longer than that. And it just got a new logo recently, a new logo. Anyway, so yeah, it has like all sorts of different colors. There's like a style book or whatever. I just wanted to show you that. I don't know. And you might be like, all right, so what's this Go thing, Kent? It's been like 30, 40 slides. You're not really going into a lot of Go, but all right, what is it? All right, I know this is a weird, long sentence, but it's a fast, statically typed, compiled language that feels like a dynamically typed, interpreted language. And that's weird. And if you go into like Go documentation and you try to like read the computer science or whatever, like I don't know what you want to call it at the end of the day, but you get really weird stuff like, is Go object oriented? If you deal with Python, Ruby, etc., it prides itself on being very object oriented, though supporting multiple programming paradigms such as functional, etc. And like literally, you go on the FAQ, is Go object oriented? The first thing is yes and no. And like, good luck, kind of digesting that. And you can kind of get an idea of like what they mean by that, which basically they took parts of object-oriented language that you like, which is like accessing stuff with like a dot syntax. Everything, like the object dot and then the methods on it, right? Everything in Go can have a method on it, like the types itself can have a method on it. And so you get object-oriented behavior in some cases, but it's not object-oriented. Like it gets rid of class. Like you don't deal with classes in Go. There's no traditional like inheritance or anything like that. You just deal with like structs and then functions that act upon that struct, where the struct is the receiver of the function. So it's basically a method. And it's like, oh, cool. All right. What does that mean? And it's like, let's just show me some of the code. And then like, well, that's where I had to deal with. Like I was reading a lot of like what Go gives me, etc. But it was really looking at the code that became a little bit more clear to me, especially as someone who does a lot of programming. And before I show you the code, I know I'm bringing some stuff that before I even show you the code, but everything in Go is a package. You'll see that at every top of every Go program there's package, because everything in Go is again a package. It's modular by design in that way, and you'll see what that means. But basically it's just because you don't repeat yourself or logical separation, though you can shoot yourself in the foot and kind of like mess that up, just like in any other programming language. But yeah, so that package thing. So we have the main package. If we were just writing a script, we would have the main package. And you could basically arbitrarily name this any other thing if you were going to build out a library based on a different name, so you don't have to call it main. It would be whatever else that you would be building. But in this case, we're just going to call it main. We're going to import another package, because again, everything in Go is a package. So even if I want to print something to the screen, I'm actually going to have to import another package to do that. And in this case, the standard library offers us a really nice way to format text and print stuff to the screen. And this is used all the time, FMT. So I'm going to import that. And this is very similar to your importing in Python, your requiring in Ruby, etc. And then I'm going to have a main function. In Go, for my programs and most of your script sort of workflow, you're going to have a main function, and that's what's going to run. And when the main function returns, that's when the program exits and all things go away, etc. So you see this in languages like C, etc. You don't see this in Python or Ruby. And this is just a little bit extra ceremony that you do have to bring to Go, though at the end of the day, this becomes very natural and is taken care of by your IDE, and I'll show you what that looks like later. And so if I want to use that package, I want to just do hello world. That's what we're doing here. I'm going to use FMT, and I'm going to do that dot syntax. It looks very similar to any other method I'd call in Python or whatever. FMT dot print line, and so I'm going to print hello world to the screen. If I'm on the command line, because this is where I like doing a lot of programming stuff, I would just run hello world.go, and that was that program that we just wrote together, and we'd see hello world printed to the screen. I could clear the screen, and you might be like, I thought you said compiled. That looked a little bit kind of like a dynamically run interpreted thing at the end of the day. I thought you said it compiled. It's a compiled language, and it is. And to compile a Go program is very simple. We just literally do, instead of run, we do build. Go build hello world go, and now. Oh, nothing returned. Okay, interesting. What if we were just ls? Oh, there's a file there, hello world and hello world.go. So our source code and the binary that we just built. If we would run file on that to check, what did we just create? We can verify, we just got a Mach Go 64-bit executable. I'm running on a Mac in this fake instance here that we could easily compile for other architectures too, and you'll see what that looks like. I could run the program, and I'd see hello world, just like if we were to run it with go run. But now I compiled it, and now this is actually something that I can go distribute to other systems that are Mach-O compatible, like Mac OS, and they could run this thing. There's no dependencies in this case that are being linked outside of it. This is a self-contained binary that I can ship around. I don't have to have you even have Go on the system. You just need to run this or have this file on the system. And this is the same sort of benefits you get with any other compiled language at the end of the day, though there are a lot of benefits, and a lot of other compiled language make it relatively hard. In Go, there's a lot of benefits that I'm going to try to get into. So yeah, and you're just chilling at work and whatever, and your boss calls your name, and you try to run the thing that you ran, or you built on your Mac, and whatever, you got a blue screen. Maybe you probably didn't get that, but whatever the case is, that's fine. If we want to build that same binary, that same hello world thing for the Windows architecture, like it's just literally setting those two environment variable things at the top, Go OS, which is going to be Windows in this case, that's what we want to target to compile for. And then the architecture, which in this case is 386. Though if we wanted to, we could do AMD 64. It just depends on whatever our system we're trying to run on, if they're 64-bit compatible, I believe. So then they could run that, and that's really great. And they're like, that's so fantastic. And I compiled that on my Mac, mind you. I compiled that source code on my Mac, that exe. I got the exe and I just copied them over, and they ran it on their system. And that's really nice. Go targets a lot of operating systems. A lot of the operating systems you're probably going to be wanting to run on in your day-to-day work. You can go just check which distributions you can actually compile for in the Go tool itself, like type go tool dist list, and that'll list out a bunch of things. And I've cut it off because it's a bunch of them, but let's just count it. There's 38 distributions that Go compiles for. If we were to try to figure out the unique distributions, not just like the architectures, I did a little bit of awk magic here to figure out that there's 11 unique distributions that we can compile for with Go. And that's really nice. Again, I can do that all on my Mac. I can build Android applications. There are minor caveats when I'm dealing with stuff like I'm linking to other libraries that are, let's say, built in C. Those can cause some issues. But if I'm sticking within the standard Go library, I'm building self-contained binaries that, again, require no dependencies, which is really nice in an operations world where I don't need to worry about whatever version of Python, Ruby, etc. And those are the kind of things that you have to deal with in those other languages. You kind of ditch those almost entirely with Go, which is kind of neat. And so you can go look at those, and those are all the things I'm interested in basically running on at the end of the day. Maybe there's a few things that I'm not running on like iOS or something like that, but I'm running on Android for that matter, and that's why like BetterCap, for example, BetterCap is a tool I like working on, right? It actually like runs on Android and performs well on Android, and that's network monitoring. You can do Wi-Fi deauthing, ARP spoofing. It's a man-in-the-middle framework. Kind of similar to like a Metasploit, though it's different scope instead of exploitation, just like monitoring and stuff like that. And it's like, well, what could I like do with that? Like if I could just like build out those things for all these platforms. So it's just like definitely not evil stuff, right? Like all these these distributions that I could write code for and easily build things out. How about something like a reverse shell? Now, I'm not going to be building a cross-platform reverse shell, though in this case, this is going to run everything that has a shell in it. You'll see what that looks like. So, package main, because that's what you can hopefully see that pattern at the end of this talk. You're going to see a lot of package. And then we're going to import some other packages, because that's what the actual convention is. I have to import those packages to do other stuff. I'm going to import the os/exec so I can run commands on the operating system. And then I'm going to bring in the net package as well, because I'm probably going to do some networking stuff. And the names are pretty straightforward in terms of like what they're going to do at the end of the day. Now, I'm going to run this main function, and then I'm going to, in that main function, I'm going to have a C2 IP and a port. So in this case, this is just some random local IP. I change it to localhost for the testing, which I'm going to show you that looks like. And then the port 80. These are just two variables we just set, right? And then I'm going to dial out using that net package, which I'm just going to make a connection. And I'm going to do a TCP connection specifically, and then I can see that I concatenate the C2 IP with a colon and then a port. And concatenate those strings together because that's the string that the Go package or function is looking for in this case. And then I check if there's an error. You'll see a lot of error handling in your Go code. You can kind of ignore that, and I'll show you what that looks like in a second. Though typically the error handling is meant to be there for a reason, and you probably want to check your errors. So if we get an error, we'll just continue on, and we'll just do this again. If we look up here, this is a for loop that has no other conditions, meaning that this is just a for loop that will run forever. There's no condition to stop it or anything like that in this case. So whenever the function or the for loop runs and then we hit that continue, we're just going to go back to the top essentially. Now we're going to go ahead and we're going to create a shell with that exec package. We're going to run a command whenever there's bin sh in this case, though we could build this out very simply with other things that we want to get a shell from on other operating systems. And then we could just pass in the standard in, standard out, and standard error to the C2 communication that we created up top there. And then we run that shell, and that's a reverse shell that calls home. And that's all the code there. That's really nice. Now, if I were on, my host, like I'm waiting for that reverse shell, and I'm just on my local host here. To be fair, I'm just going to do a netcat listen, and I'm going to do a verbose, and I'm going to whatever port I'm waiting for the communication back. The verbose specifically, so I can see the connection from wherever. In this case, just from my local host. But that's fine. I could run who am I could check who am I, and I could run basic shell things, because again, it's a reverse shell. I just got a shell on the box. Now, we can get into things like how you even got the shell to run in the first place, but that's sort of irrelevant. We just have a binary that now is a reverse shell that runs very nicely. We could do that in a while true loop to continuously communications back, just like the C2 shell is always trying to call back home. We're just going to wait. Even if we accidentally control C, we'll get a new shell back basically right away. That's not too bad. It's not multi-threaded or anything like that, and we'll get into some multi-threadedness, but it's not too bad. Like that wasn't bad at all. And how about a port scanner? I like building out these small little tools in a programming language in order to kind of get the effectiveness of like what I'm going to be able to script out later on. And so like building a reverse shell, a port scanner, those things usually become very helpful to me to kind of grasp like what are the workflows that I'm going to need to build out other applications. So a port scanner, I like that. So a package main, very similar to every other Go thing. It always starts, in this case, with package main. We're going to import some other packages, because that's what we have to do. We're going to do the FMT, because maybe we're going to print some stuff to the screen, or maybe just do some string formatting. We're going to import that net package in order to do some network communication, and then time. And we'll see what we're going to do that, but maybe we're going to have some time-related stuff going on here, right? So, we're going to have a target host, and now I'm showing you what a struct looks like. I said before that Go totally gets rid of classes. There's no object-orientedness in that regard, though we can still have basically this named piece of data that has some internal information about it, and we can apply functions on that struct. So we'll see what that would look like. But basically, we have a target host, and all it basically contains is the IP address. Now, you could obviously just have this be a string, though I'm just trying to show you structs are relatively simple to construct, and that's just fun. Anyway, so an IP is a string, and then I'm going to create another function where I'm going to check if there's an open port. In this case, I'm going to just show you how to build that function out, because otherwise, just get that, right? So I have an IP, it's a string, because I'm going to want to check an IP address, or check a port on a specific IP address, the port, which is going to be an integer, the timeout, which is going to be just a time duration, because I don't want to wait forever for a port that never closed or anything like that. And basically, at the end of that function, I have a bool, because this basically is going to return true or false whether or not the port is open or not. So I'm going to have to do that net dial, but in this case, I'm doing a net dial timeout, because again, I don't want to wait forever. I don't want to waste my time. I'm just going to wait basically a second to, I can specify this later on. I'm going to do TCP connection. I'm going to do a little bit of FMT magic in order to take that IP address that was a string and that port that was an integer, and then concatenate them together and specifying like what types they are with this little sprintf magic. And this is very similar. You'll see this in a lot of other programming languages in order to like manage your data like that. And then I'm going to pass in the timeout, whatever the timeout was given for this function. So if we didn't get a connection, so if the connection was nil, we're just going to return false. And this is what I mean when I'm saying that you can kind of ignore your error handling in Go in some cases. Because if I look at this, comma and then underscore, that underscore would traditionally be your error. Though if you give it an underscore in Go, you're basically telling the Go compiler you're not interested in managing with that ever. So you're never checking your error in this case. You're only checking your successful case for the connection. So there are cases where you can kind of get around having to do like that error dot not equal nil, panic the error, or anything like that. You can kind of get around that, though this won't be necessarily the best, because if you hit bugs, you're not going to be panicking and showing the errors. But in this case, we're just checking open ports. We're going to get around that. I'm just trying to make it run fast and write an example, right? If we did get a connection, we're going to close the connection, and then we're going to return true to check that the port was open. Great. Now we're going to find open ports. So this is going to be a wrapper to that other function we just wrote, the check port open function. And then we're basically going to have the port we're going to start at, the port we're going to stop at, and then we're going to return a port, a slice of ports, which are basically the ports that we found that were open. If we want to use that, all we have to do is do function main, because we have that main function in Go, and we're going to set the target host, which is just going to be our local host, and then we're going to find open ports starting on 1 and ending on 1024, right? That's really great. Now I can just print out the results, and if I were to run that, I could check that I don't have any open ports on my system, or at least, yeah. Oh, well, this is all just writing it like sequentially, like if I were writing the function. So this is all like within the script itself. I'm not showing all the functions that we just wrote ahead of time. But yeah, so like if we were just like sequentially writing this sort of like line by line, function by function, building that out, now we have those functions ahead of time outside of our main function. Now I can call them here. So now I could just do, I could verify that there's no open ports, at least in this case, and then I could even check how long it took, which is right now 7 seconds. So let's try to speed that up. Let's do some of that multi-threading. So, and this would be the case if I did have any open ports or something like that. So let's talk about some of that concurrency. You hear really in Go that concurrency is where it shines. And that's true. In many cases, concurrency is 100% where Go shines, though it also acts really nicely as just a scripting language without having to deal with any multi-threading concurrency BS in the first place. Basically, what your concurrency is, if we don't know what that word means, basically it's making simultaneous progress on tasks. These could be independent tasks, could be tasks that like work together, but they may have independent workflows that we have to like manage, and so that's what concurrency is in that case. And there's a whole talk in like the difference between concurrency and parallelism, and we could totally get into that, though that's totally outside the scope, I think, what this talk is. But basically, trying to visualize what we're trying to do here is that, well, we had the first port and we had the last port we were interested in. I'd like to basically distribute out that workflow, do all that work on every port, manage that, which this blue block is trying to do here, and then all the results feed into a central place, at least in this case. This is the algorithm I'm sort of looking to implement in order to do my port scanner. I want to not just do one port at a time in this case, but maybe I want to do lots of ports at a time. There's cases where you can blow out the amount of ports that are being able to be open on your own system, which is really funny. But anyway, in this case, this is what that would look like, and one way we can implement that. This gets into a little bit more of like syncing together these separate Go routines, but basically we have ports, which are basically going to be that stream that we're going to just return right at the end. So this is going to have all of the ports that we find that are open. we're going to have this thing called a wait group, which is basically going to allow us to wait for all the Go routines that we go and spawn to finish. Because once we have them go out and do something, we have to have them have a way to go check back and say, oh, we actually finished our work. This is one way that we could do that. Now, for each port, we go over them, we add basically a count to the wait group in order, we're going to wait for that Go routine because we're going to do it for each port. Now, we're going to basically spawn a Go routine right here, where we're going to take that port, we're going to, when it's done, tell that the wait group is done, like we finished our job, and then we're going to check if the port is open. This is very similar to the other API doing this, the normal find open ports, but now we're doing async find open ports, spawning a new Go routine for every port, and then waiting for that data in the ports channel. And then before I return the ports channel from that function in order for them to wait on it, I'm going to have another Go routine go and close the ports close the ports channel when all the Go routines have finished, and that's what this wg.wait basically is signifying. I'm waiting for all the Go routines to tell me that they have finished here, which is right here. So this does require a learning curve at the end of the day, though I have done a lot of multi-threading, a lot of multiprocessing in other programming languages, and this makes it significantly easier in my opinion. I don't have to deal thread.new. I never said thread.new ever. I did have to bring in this little thing called a wait group, though I'm okay with that in the sense that I know that I'm going to be spawning a bunch of work, and I know I'm going to have to tell them that they're done anyway. So this provides me a succinct API in order to do all the work that I would be doing in those multi-threaded programming languages like Ruby or Python, etc. Though I get, again, a cleaner, succinct API to do that. And this is really nice because now I get, start port, end port, and then this is sort of just a transparent thing that happens, and now I'm just going to be reading from that orange block there, which is going to be my open ports. And all that kind of Go routine stuff has been, managed for me if I was the user of this library. And so I'm not really thinking about that being a multi-threaded behavior. All I know is that I can create a target host, and then I can asynchronously find open ports. In this case, I'm ranging over that channel in order to basically iterate off of each port that I see. And so for the port, I'm going to range over that, and then I'm going to basically print the port to the screen. So I could run that, and then I could see that only took me a second to scan all those ports, which is really nice. So basically, I spawned a bunch of Go routines. They went and checked. They either failed because they could make a connection, or my operating system, Mac, by default, only allows you to have 256 open connections at once. So it probably hit that error before it even could make the port scan. But what's really nice is that it only took the 1 second as opposed to the 7 seconds in order to build this asynchronous function. And if we were to lower the timeout down from, I believe the second that I had in there to like nanosecond, this becomes much faster, though you won't even like see the open ports because you're closing out the connection before you even get a response back. And at the end of the day, you could probably just use mmap to do this similar thing, right? This does provide a really nice way of getting an idea of like what's happening behind the scenes. And I really like Go because it allows me to write something that's genuinely really fast, and I get a lot of control of what's happening with that port scan. If I ever do an nmap thing, I'll hit some weird stuff. If you do like VVV while you're running the thing, you'll see that like, oh, I hit the max connections, and so I'm going to do a back off, and so I'm not going to try to scan as fast. In some cases, I'm going to want that behavior. In other cases, I'm not going to want that behavior. And I'm sure that's an nmap flag or something like that, but I could just write some Go code. And again, it's the simple multi-threading that I think it provides, and it provides it in a way that's much different than all other programming languages you're probably dealing with, specifically Python, I'm trying to get at here. In Python, and this is the exact same thing for Ruby, though I'm just using Python because if I say Ruby, sometimes just people's ears turn off. Maybe it's because I say Ruby a lot. But in Python multi-threading, I see a lot of multi-threading in Python stuff. You get this really interesting behavior that you may not be familiar with, but you may be familiar with. It's the global interpreter lock. You have the exact same thing in Ruby. I believe it's called the global VM lock instead, though. But basically, you can do like thread.new. You can spawn as many threads as you like inside of that language in Python. But there's only going to be one thread running at a time. And so that's sort of upsetting when you want multi-threading behavior, that I'm only going to have one thread be able to run at a time, no matter what I do, essentially. And so if I want to get the most power out of my multi-core system, where I can have a lot of threads running at once, I don't really want this behavior. And what's nice about at least Go is that Go was written in a time where we had multi-core CPUs that we wanted to take advantage of. It was written like 8 years ago. We had that, right? Python, Ruby, etc. were written when we didn't have that kind of power. That kind of thought wasn't really taken into consideration at the beginning of the language. Go, at the beginning of the language, knew that we had that power, and we want to expose a way for them to not have one thread run at a time, but literally have all of our threads go, or have most of our threads go, and have a little context switching there. But that's what happens. And so to get around that, you usually have to spawn multiple processes in Python if you want to have any sort of more than one thread running at once, which is literally you like forking a Python process or a Ruby process or whatever, and having that global interpreter lock for that specific process allow one thread in that process to run at a time, which means, at least in this case, we could have 2 threads run at once, but I'm requiring 2 Python processes to be running when I could just have like one Go process and potentially even not have the same problems. So the simple multi-threading API really comes down in Go to really just like Goroutines and channels. Like those are the 2 things that you get to wrap your head around in order to do multi-threaded programming, which changes a lot of the stuff that I would traditionally think about, where I would think about like, okay, if I was going to do this in Ruby, I may have to think about, I have to fork a process, and if I wanted to do some sort of background behavior, do inter-process communication through like a pair of pipes in order to like basically manage that myself. In Go, I just get the Goroutines and channels, and I get that same sort of behavior, but I get, again, a cleaner, more succinct API in order to do so. And so I got a lot of asynchronous streaming behavior really easily in Go, and here's just like kind of an arbitrary example where like I have the package main, I import FMT, right? And then I have the example, some example numbers, and I basically want to have the sum of the numbers, right? I could do that very simply if I wanted to kind of do it like an async behavior where I don't want to like wait on the sum of numbers. I want to have it come, basically I can say like go find the sum of numbers, and then when you can basically tell me those sum of numbers, you can basically just tell me through the channel. And so in this case, I make a channel that's going to be an integer, a channel of integers. I have a Go routine go off into the background, and then basically find the sum of numbers, and then once it has that sum of numbers, it's going to tell that channel. Once this is done, it literally closes that channel, and so I don't have to deal with any more cleanup. So just in this very simple usage, I could do format print line, the sum of numbers, and then with this arrow syntax, I'm reading from this channel, which means that it is blocking in this case. But if I were to do multiple of these in a in multiple Go routines or something like that, I could then just do a simple sort of for loop or a select over these channels in order to read for the one that is actually available for me to work on, which means I could build something like an event loop actually pretty simply, which is really nice. And you're probably going to do some multi-threading if you're interested in Go, and you might run into some bugs. Even though you get a nice, clean, succinct API or whatever like that, you're a human. We write programs, we has the bugs, and so we would like a way to fix this, or deal with that at least. Not fix it always, but deal with it, right? So debugging in Go. And this is a kind of a really interesting part about Go that I kind of fell in love with in many ways. One thing about Go that's very interesting to me is that GDB, the GNU debugger, basically, if I were doing like static analysis, that would be like something like Binary Ninja. If I were doing dynamic analysis, I'd probably run something like AltAdebug or GDB. GDB, I could actually like run the process, and I could set breakpoints any point in that process, read the process's memory at any point, and basically do some interesting things there. To basically get an idea of what's going on with that application, that program. Whether it's like a program that I wrote myself, or like, let's say, maybe potentially a malicious piece of code. What's interesting about Go binaries is that it actually has a different execution model than what GDB is expecting, which means that GDB can crash when you're doing your dynamic analysis for your Golang binaries, which is relatively interesting. And this is a known bug, so to speak, though. Coming from like my mindset, I see that as like a really interesting feature where it's like your code that if I wrote like, let's say, a cross-platform malware in Go or whatever, and you were to try to do any sort of dynamic analysis on that with GDB, you have the inevitability that could crash on you because it's or not even analyze it correctly, which is kind of scary in many ways. Or even in my static analysis in Binary Ninja tends to choke. And this isn't the only language Binary Ninja has some problems, specifically because Binary Ninja is really built for like C, C++ sort of debugging. And so when you have this programming language that, I don't think I mentioned this yet, literally threw out all of that work that C did. Most programming languages, at the end of the day, probably have some sort of C backend. In Python, it's written in C. At least our traditional Python, it's like Python. And Ruby, we have the same thing. The Ruby VM is written in C. Most programming languages have to deal with C at some point. I like Crystal a lot, though it has to deal with C at some point. Go is very special in this case, that it literally threw out all of C. It got to a point where it was dealing with, it was at a point where it did have to have some C code, but now it's at a point where there's literally no C code. So when I do those Golang binaries, I'm not dealing with any C at all. So when I have something that's meant to understand C, C++, and then I give it Golang stuff where it doesn't understand, it tends to crash or have a lot of problems, which is really an interesting interesting feature for the language, in my opinion, where my analysis actually comes a little hard if I'm not even compiling the program to be debugged. And so if I were to come across some Golang malware, I'd imagine that would actually give me some interesting problems that I wouldn't necessarily know how to deal with right away. And so it is still debuggable, though, because I still want you to be able to debug stuff at the end of the day. The Golang project, the community, one of the community members, Derek Parker, came out with Delve. It's a debugger for the Go programming language. And that's really great. So you can still debug your Go code. We just have to type delve debug, and we can set a breakpoint, break on main, and then we can type continue in order to continue on until we hit that. And we hit that breakpoint right there, and then we could do some stuff like print out variables that are there, but nothing's there for us to really look at. We could disassemble and look at the assembly at that point. We could look at the threads that the Go program is actually spawning on multiplexing for those Go routines to look at how many threads are actually running at once, because you're potentially expecting you're writing a multi-threaded program, though Go is kind of interesting. The Go runtime, if you don't understand it, it may not even multiplex those Go routines onto real threads for you. So you can actually go check it and see that, oh, you're multiplexing under real threads when you need to inside of Delve. But what's kind of interesting about that is that you actually are required to have the Go source code when you do your Delve debugging. So if I was a malicious actor and I was releasing a Golang binary or something like that, I don't have the source code. So Delve doesn't even help me in that case. So the traditional solution to Golang debugging requires the source code in this case, which is another interesting sort of feature in my opinion, where it's just all right, sweet, no, your debuggers don't really work. And one thing, I guess I lost that slide. But one of the things also help make Go fast, and one of the things I like about Go is actually the static typing of it. You may not like static typing at first. I had some friction with it at first, but though it was only after I kind of understood what it was giving me, and I actually came to love doing my types. But basically, it has a small memory footprint. Oh, and that's where that slide went. But basically, if in Go I were to create a variable, I could specify exactly how big I want this, which is going to be an int 32, which is going to be 32 bits, which is going to be 4 bytes. So I can store this 2018 BSides Detroit variable really nicely, and I can specify exactly how big it's going to be. Oh, there it is again. Anyway, right there, 4 bytes, 32 bits. If I were to do this in Python, and this is Python 3.6.5, this object would be 28 bytes. So 4 bytes compared to 28 bytes, I could store many more Go routine integers than my Python integers. And just specifying variables alone, I start to actually get performance benefits, specifically because I'm not dealing with literally as much, which is kind of nice. And then I get a really robust standard library. All the Go programs that we've written thus far have all been part of the standard library, which is pretty interesting. In other programming languages, it's really sort of standard in order to actually not use the standard library, but to use third-party libraries that are wrappers in order to deal with the standard library in a much nicer way for you. In Go, it has a really robust standard library, so much so here's one of the things that I really like. And this is built into the Go standard library. This is the debug/PE package. And this one allows me to do debugging, a static analysis of PE executables. And this is this is basically Windows portable executables. So if I were to use that API, I keep saying that Go provides simple APIs. If I were to use this one, I would open up my sample.exe. I would do some error checking that I could kind of ignore if I wanted to, right? Which I'm going to do right here. So let's do that error ignoring. We're going to close the file once this function is finished. So that we can imagine this in a main function. And then we're going to find the symbols, the imported symbols, out of that PE file just by doing this. So that file dot imported symbols, we get the symbols. This is where the error would be, but I'm ignoring it. And then I'm going to range over basically that slice or that array of symbols, and then I'm going to print them to the screen. And so if I were to run it, something like this would be seen. And this specifically running on a Golang binary that was compiled with Go, PE that was compiled with Go. And so I could run and get the imported symbols, and I could build this out into a much nicer command line application that didn't have a hard-coded sample.exe path or whatever. But, I hope you get the point. And it provides other nicer things where you don't just get like the whatever we were doing before. We can actually get like how about some section info? So the section header, and then we get like the name out of it. And notice how we're doing like our nice little dot syntax in order to like access things as we would in other programming languages like Python and Ruby. And this is again built into the standard library, which is, I think, very nice. So we could, just basically do static analysis, building all these tools out in Go, literally using the standard library, which I really like. And this is, I believe, used by both VirusTotal and like companies like Malwarebytes. Like people are using this, like the Golang standard library, in order to do like static analysis right now, which I think is great. Though you obviously can do third-party packages, like in most other programming languages. And so what does that look like? Well, we could just literally run go get, and then this is the path to like a GitHub repository, basically, and that's how we distribute our packages in Go. We don't have a central package repository like we do in, let's say, Python or Ruby, where we have PyPy and we have Ruby gems. In this case, like I'm just like putting it up on GitHub, Bitbucket, whatever, and that's my package repository. That's how I bring in other packages, like just through a link that I can know where the source code is very easily, copy-pasting that to my browser. And this one, just like pulling in my favorite command line application, interface builder. And so we could build something out with that pretty simply, like package main up top, and then importing that package we just went and did the go get on. So I built a lot of tools with your fave CLI, well, my fave CLI, right? But it's one tool that I built that's open source on GitHub right now. It's a domain availability command line utility. It just has a nice ring to it, I think. But essentially, it's written in Go, pure Go. It's like 10 stars. That's great. It has two contributors, me and another guy who I really like a lot. A great shark. And then that's the GitHub link. So this is what that looks like. So this is what that your fave CLI package gives me. At the end of the day, a really nice way to build up command line applications that look pretty cool. So in this case, if I had is it compiled and blah, blah, blah on my system, I could run it, and then this would be like the default help menu. I could do like, is it available? Is it registered? Is it resolvable? Is it up? And getting true and false with the domain name. And I can also do multiple domain names. And when there's multiple domains, this will do concurrent lookups under the hood for you and then give you the results. So to build that, we're getting towards the end of it. To build that, we import a lot of other packages. So you're probably going to import a lot of packages in Go when you're building out tools, but that's fine at the end of the day, because these packages are like doing very specific things, and there's not a lot of bloat. There's some bloat because you're not going to use all the functions in the package, but there's a lot of stuff that I think is doing really good here. So we import FMT, that GitHub thing. So that's the only third-party package in this case, and the rest of them are all standard library packages. I can create constants in Go, which I haven't showed, but this is a string that isn't supposed to change ever. Basically, a whois.com link, because I'm going to do some whois stuff, but I'm going to use basically whois.com instead of like doing a traditional whois. And then is up or not, which are the down everyone or just me.com domain. And I'm going to use these two later on in order to do checks. And then since this is all most of them are using HTTP stuff because we're using those two websites, and we're going to be speaking HTTP, just doing basically a connection out to them and trying to get the results back, right? So in this case, I'm going to create the special variable called net transport, which is basically just going to have configurations for my HTTP client that I'm going to build out in this next thing, where I have net clients, where I now have a timeout of 10 seconds, and that net transport that we just built. Now, I build out the rest of my functions that I'm going to use in my library, in this command line tool. Is registered, is up, is available, is resolvable, and then I build out the rest of the things like if there's no arguments given, and I, error out. And then I build out my type result, because this is going to contain the result of the domain and whether or not it was up or resolvable or registered, depending on what we're checking in this case. But we're going to reuse this everywhere. And then I can build out my command line application. This is the kind of DSL that your fave CLI gives me, where I can create a new application, I give it a name, give it a version, I give it that nice little usage statement, and then it has some commands, because I'm building a command line application after all. So this is where I'm going to put all the commands, which I'm going to build out next, right here. Oh, and then before I do that, I actually have to run the application. No big deal. With the arguments that are passed in from the command line, with that os.args. So I create a command called available. I create a command called registered, and if we kind of go back and forth, like literally, I am copy pasting code in order to make those things, and I'm just like plugging in is available or is registered into the value thing there. And so building out those is pretty simple, and honestly, I could probably make this a little bit more drier, just passing the data around as functions themselves into a larger function that wraps that up. But even so, like just copy pasting inside of Vim or whatever I'm working in at that time is pretty straightforward, and just like changing the things where it does change is not bad at all. And now that code is available on GitHub, etc. You can go download it. I really like Great White. He contributes to some of my stuff, and I just love him so much, so I just want to put him here. And it's like, great. That's all we really had to write. Oh, boys. All right. Hey, Mom. I'm doing a conference talk right now. I'm doing a conference.
You're on video.
You're on video. You'll see this later. All right. Sweet. That's great. A little surprise appearance from my mom. Anyway, so yeah. We can high-five each other about that, etc. And then developer tooling in Go has a really nice developer community. The tool that I really love the most right now in my workflow is VimGo. You can, if you like this project enough, you can help pay for it if you wanted to. It's a really great project. I recommend you check out if you're at all interested in Go programming and you like Vim at all. Like VimGo will save your time in so many different ways. Like it helps you catch different stuff like missing colons or missing brackets, etc. So you can go check that out, and it's really trivially testable. We're building out applications. Maybe we're going to actually want to write tests at the end of the day with all these applications we're so interested in writing in Go. A very simple way that we could write tests in Go is just using the standard library. So it's just our example. We're going to add numbers, taking in two numbers, and then returning a result. We could import testing. And so this is to be a separate file that would exist alongside our file that we just created with the add numbers in it. Still, we're going to do package main because it's at the top of every Go program. We're going to import testing, and then we're going to have this function called test add numbers, which we're going to pass in the testing suite basically here. And then we have an expectation of we're going to get 10 from the result of the add numbers, and we give it 8 and 2. So we expect 8 and 2, add together, get 10. And if what we expect isn't what we got, then we're going to error out. To test this with the test that we just wrote, all we have to type, and this is just showing that we have add, and we have add underscore test for our tests. In Go, you have to do like underscore test in order to show that this is a test, but that's fine. I'm just going to clear the screen to have more room. And then all I have to do in order to run my test is literally just type go test. And it runs my test. And it shows me that in this case I passed because I know how to add numbers and I know what to expect. Right now I'm going ahead and I'm going through the BetterCap code base and trying to add tests for it. And this is a code base that I think would be really great if you're at all interested in doing open source community involvement or anything like that. BetterCap right now is trying to have full test coverage of its code base. BetterCap there really needs more contributors in order to give the full testing that it needs. So I would think that if you're at all interested in Go and you're all interested in open source at all, BetterCap and the testing, just to get BetterCap to a full 100% test coverage, this is a great project in order to start working on, honestly. And just writing like literally those like this kind of test in order to test out BetterCap. So it's a little dull, to be fair. Writing out tests isn't the most fun thing in the world, though you don't have to go and decode some test suite at the end of the day. Like this is a very simple test suite that provides a very slim API in order to actually test code. So that's all you got to do there. And we're working on it. It's not even close. Like you can see, like we're at like what 20% like line coverage or whatever. But the core is very close to being fully covered and stuff like that. And I'm very happy to at least gotten that far. And all you have to do is just use the standard library for testing in this case. And you can go learn all about the testing standard library. There's lots of open source projects that are being built in Go right now if you don't want to just contribute to BetterCap. There's like plenty of reason to learn Go in that in this case, I believe. Just like these are just some like arbitrary stuff. Like Kubernetes is built on Go. People are writing like command line tools to make like JSON greppable. I love that. I love GoTop, which is like a terminal-based graphical activity monitor inspired by GTOP and VTOP. And that's beautiful. That's all written in Go. So like, how about you write your own? So that's all. I can have a little time for questions, but you can follow me on Twitter at Kent Gruber. And yeah, that's it. So any questions, or are we good? No worries. Perfect. Thanks.